Osmium tetroxide is also there. Answer given is A here.
Sir?
Answer given for this is A or B?
I think they gave B. 1 second.
I'm not sure about the mechanism here, dude. Sincerely. Because this is definitely going to involve an epoxide formation followed by hydrolysis.
So B is given, sir.
Mostly B is what I was expecting also. After you, I think you mentioned B is only just now. So your memory is not going to be that bad anyway. So mostly it will go via formation of A first. Then it will mostly go for regular hydrolysis. But in that case, you should be getting, what to say, oh yeah, damn it. There is no A or B here. What the fuck? It is normal only. There is nothing complicated. B is the correct answer only. There is no confusion here. Let me quickly tell you what is expected here. You'll end up having normal, what to say, in the first step, the amine oxide. That amine oxide which is present there will effectively release nascent oxygen. Okay, which will end up performing epoxide formation, which is quite straightforward, yes?
Yeah.
Then you'll have hydrolysis.
Yes, sir.
Now the hydrolysis is going to be resulting in what product?
Dihydrogen. Diol, my bad.
Epoxide will undergo the hydrolysis, it will give you OH.
Yes,
Our issue is it should be on opposite side, correct?
Sir, can you repeat?
If I'm going to be doing hydrolysis on an epoxide, what do you get as product?
You get anti-addition.
That's the thing. There is no anti-product here. Anti is applicable only when there is what?
Chiral.
Yes, is that chiral?
Huh?
Is that chiral here?
No, there's no chiral.
That is why B is perfectly fine here. You understand what I was talking about over here? That is, in the sense, the product option B only looks funny. It is not a funny option. It is a normal option only. You do your anti-addition on this. You'll be getting your regular, what to say, your expected product is supposed to look like this in your brain. Right?
Yes,
Look like this in your brain. I'm telling you this and that are the same.
Yeah, they are the same. But then, no, I didn't even get to that stage. I mean, I got confused in the, like, I saw the solution, they gave some weird explanation. I'll just send it once.
Send it.
Photo.
Basically, they're telling you the same thing, Rab. They are telling you that this reaction, effectively, they also were not clear with what is expected to happen. This is like one of those bullshit reactions, which is, well, how to say, normally played with. If I'm having reacted with, say, Bayer's reagent or osmium tetroxide followed by hydrolysis. Like Bayer's reagent. What is Bayer's reagent?
Cold dilute
Cold dilute alkaline KMNO4.
Yeah.
So if I'm going to be using that, or if I'm going to be using osmium tetroxide followed by hydrolysis, what is expected to happen here? You are supposed to have syn addition, correct?
Syn addition, yes, sir.
So what they are telling you is that this particular reaction, they expect it to give you the syn addition only, not the anti-addition. All right. But their explanation is that you're going to be having osmium tetroxide being the actual oxidation substance over here. And then this given is actually this only. Osmium tetroxide followed by hydrolysis is what they are telling you this reaction is supposed to be. But on the reaction giving you osmium tetroxide part there, what is expected to happen is osmium here in +8 is expected to go to +6 during the reaction and get consumed in the reaction normally. But if you are going to be having this osmium +6 in the presence of amine oxide,
nascent oxide is provided. Something.
That nascent oxygen which is going to be provided is going to be oxidizing this fellow back to become osmium tetroxide.
So it's like infinite supply of.
Not infinite.
I mean, amount of how much amount of amine oxide that's in.
Basically, they're telling you amine oxide is the actual ultimate oxidant over here in this reaction here. So What their excuse over here is that since they do not have any confirmation for this, the expectation is that it is supposed to be sin addition only. They have come up with some nonsensical logic for this to work over there. But they are also not sure. And they know this is going to not stand most often in any real scrutiny. So what they did was they basically made sure that the product or the compound they gave was something which is very obvious. And what to say, they just made sure that there is no argument at all. Whether it is sin addition or anti addition, it doesn't make a difference in this compound here.
This compound doesn't, yeah.
But in reality, what they are trying to tell you is it is going to be actually doing sin addition. So you can remember it. There is a good chance that this kind of nonsense is something which some teacher, if they find proof for this truly, they might think like, oh, wonderful, this is something we can screw with students. One of those exception type of things. So yes, you basically recognize that this is something which, or you're starting to recognize a weird, exceptional type of nonsense once in a while now.
Yes, sir, yeah.
So definitely, yes, this is one of those weird shits here.
There are like a few like.
Same thing. Do not worry so much about these kinds of things. If you notice them, take them and keep them in your brain. But try to understand they are never going to be realistically meaningful. They will only be really useful when it comes to scoring in internal exams, predominantly. But they are useful. They are good confidence boosters.
Yes, sir.
They tell you that you are on the right track if you start recognizing this kind of crap as well now.
Yeah. Sir, like a few places, this iodolactonization thing came.
Oh, by the way, this is new to me also. I've also not heard of this thing.
Oh.
Go on.
So, like in a few questions, they were asking what will happen if you with an alkene you add iodine and sodium bicarbonate. So iodolactonization, they said. What exactly is it?
Alkene and iodine and
sodium bicarbonate, NaHCO3.
lactonization.
Iodolactonization, yeah.
Lactone, that is going to be something which is a cyclic ester.
Yeah, yeah. I can send the question.
In this particular case here, if you want to do some cyclic ester type of formation, give the exact reagents. I don't think it is a feasible reaction, logically speaking. But if you have the reagents and if you've got the auctions case, oh, this is different. This is a different thing. Okay, chalo, so let's start talking about what's expected here. So it's not an alkene. It's a carboxylic acid.
Oh, my bad. But even in another question, there was.
No, carboxylic acid is the key thing here.
1 second. There was one question.
Okay, so iodine will end up having your internal ring type of thing which is going to be formed here. The cyclic three-membered ring which is going to be formed with a halogen in the middle. So we'll end up having this bond disappearing, or actually I'll just put it and then show. Now, before we go into the reaction here, NaHCO3. Do you remember the acid-base reaction thing, the acid-base order which I gave you?
Yes, sir. Yeah.
What was the position of H2CO3? Carbonic acid. Was it stronger or weaker than a regular carboxylic acid? Let's say I'm considering H2CO3.
It was more.
Don't jump to conclusions. That is based on your memory, right? Yes. Memory is fallible. Logic is not. So go for logic. So draw the structures, structures for regular carboxylic acids, right?
Yes, sir.
Put them up and then compare. So this is a typical carboxylic acid, acetic acid, and this is my carbonic acid, correct?
Yes, sir.
So if I'm going to be having this carbonic acid and the carboxylic acid, which parts are common? This part and this part are the same?
Yes.
Right. So if this part and this part are the same, now I just need to compare the two groups on the side, which are basically going to be this guy and this guy, and see their effects on this. Correct?
Yes, sir. Yeah.
So now, what is the effect of this OH and the CH3. The CH3 is a plus side.
Plus side.
Whereas the OH is going to be what type?
Minus. Plus and
Plus R and a minus side.
yes.
Right. And which one is going to be more dominating? The plus R is more dominating?
Yes, sir.
That means among the two groups over here, the OH and the CH3, which is a more electron donating group here?
Plus sir. The OH.
OH. That means if the carboxylic acid group is going to be having a better electron donor attached to it, is it a stronger acid or a weaker acid?
Weaker acid.
Good. So now, which is a stronger acid then?
The right side one, the carboxylic acid.
Carboxylic acid, which means carboxylic acids are stronger than H2CO3, right? So if I'm going to be having, say, a reaction like this, RCOH plus HCO3 minus 1, if let's say I have an equilibrium, the equilibrium should result in RCO minus plus H2CO3, correct?
Yes, sir.
Now, how do I decide which direction the equilibrium will be moving in? Whichever side has stronger species.
Stronger acid, stronger base.
So let's start now looking. So RCOH, which are my acids here?
RCOH, H2CO3.
Which one is stronger?
We just decided the R one is stronger.
Stronger acid?
Yes.
Weaker. Which is my stronger base here? Which are my bases here? HCO3 minus and RCO minus, correct?
Yes, sir. So whichever, 1 second. It should be the
conjugate, right?
Yes, sir.
Conjugate of the weaker acid will be stronger.
RCOH.
So RCOH is stronger acid now. RCO minus is weaker base.
Weaker base, yes.
So this is going to be stronger base.
Yes.
This is not strong acid, strong base, stronger.
Relatively, yeah.
So obviously this equilibrium will be in which direction?
Backward direction.
Backward or forward?
Sir, forward direction, my bad, sorry.
Forward direction. That means this equilibrium will be producing H2CO3. H2CO3, is it stable?
Yeah.
Do you have, if I'm going to be having a soda bottle, like say a can of,
shaking.
a bottle of Mirinda, I'm keeping it open. What happens to it?
The gas escapes.
Well, what do you mean by gas escape? It's supposed to be carbonic acid inside, right?
Yes.
So what's happening?
Oh, it turns into.
It decomposes.
Decomposes, yeah.
To give you H2O and CO2. That means in this particular case here, go back to the reaction here. If I'm going to be hitting this with I2 in the presence of HCO3 minus 1, what will HCO3 minus do first?
1 second. It will first dissociate.
It will go react with what? Is it H2CO3 here or HCO3 minus?
Oh, my bad. Sorry. HCO3 man, it'll pull the H from OH. Yeah.
So it will go react with that guy. It will become H2CO3 and then get out as H2 and CO2.
Yes, sir.
I'm going to be having what now? I will have this guy.
Yes, sir.
Correct?
Yeah.
Now this fellow is attacked by I2.
Okay.
So क्या होगा अभी बोलो?
I2 if it comes, then
we will have this
the double bond, the thing will come.
And we'll be having carbon and we'll have C double bond O and an O minus.
O minus will donate and then
donate or attack?
Attack, sorry, I mean.
So it will end up attacking.
Yeah. And then one I will go away. Yeah.
I suppose you understand what's happening?
Yes, sir. So like in these general cases, here the oxygen can attack either place, no? Either one of the carbons.
Think. We have done neighboring group participation. I think I touched upon neighboring group participation.
Yes, sir. Yeah.
Correct. Oxygen, what type of rings will it form?
Oh, that 3, 4, 5.
5 and 3 and 6. 5 and 6 are more preferred. 3 is the next preferred. 4 it doesn't form.
Oh. Okay.
To go back and revisit things and start connecting the pieces.
Okay.
Oxygen prefers to form 5-membered rings mainly when it is part of a normal long chain. In this case here, it can do three-membered ring also. Why? Because it's part of a carboxylate type of system. So it can do three-membered, but it will avoid doing four-membered.
Only 5, 6, and 3.
Sulfur, on the other hand, can do four-membered also. Why can sulfur do four-membered? I remember we touched upon this also. I've given you an example of some comparison involving bond angles. Which bond angle did I compare it with?
One or the tetrahedral.
Yes, good.
One
Which
or
example was it for sulfur, which I asked you to think of?
wait.
Correct. You went in the right direction. Go.
H2S.
Correct.
Yeah.
You understand now what the link is going to be there. So oxygen cannot do a 90-degree angle. Sulfur can do a 90-degree angle mainly because whenever it is going to be forming the H2S type of system, it does go for the 90-degree naturally there. Sulfur, phosphorus, those guys like to go for 90-degree angle or close to 90-degree angle. Whereas oxygen and nitrogen do not like 90-degree angle or anywhere near that. Mainly because oxygen and nitrogen are going to be having, no extra orbitals available to delocalize any they're going to be having. So the repulsions between their lone pairs will be extremely high if they are on 90-degree angle. So they will avoid that type of system. If you look at this actually has a lot more significance also. So please try to remember sulfur as something which prefers to go for 90-degree bond angle. You will have this connecting again in biomolecules as well. In biomolecules, there are some specific amino acids, which when you're going to be having proteins are basically going to be long chain amino acid polymers. Okay. What happens is when they are bending, when the protein molecule is bending, in some cases it will have to do a 90-degree turn. Wherever it is doing a 90-degree turn, there will be a sulfur-based amino acid present there. Wherein the sulfur will basically facilitate that 90-degree turn properly there.
Okay, got it. Sir, you said in the case of nitrogen also 90 degrees is not favorable, right?
Yes.
What's the reason for that? Oxygen, you said lone pair repulsion.
No, basically it's not really lone pair. Think logically. It is lone pair is just a bloody excuse I give. Lone pair is not the correct reason.
Okay.
I really do not have an exact logic over that. In the case of water and shit, we can argue with lone pair. But in reality, lone pair is not a proper excuse. Because the fact is, if I'm going to be having 90 degrees, the lone pairs will have more bond angle between them. So technically, the repulsion should decrease. 90 degrees of the other bonds. Let's say like 2 bonds at 90, others are going to be lone pair, na?
Yes, sir.
They should have more space.
Correct.
I'm not exactly sure if the lone pair shit is the logical excuse. I've read that shit somewhere or somebody has argued with me about that, but that's just a flaky excuse.
Okay, sir. Yeah.
I've not been convinced with it, but I do know that 90 degrees is preferred for sulfur and not for nitrogen and oxygen. I do not have a proper logical reason. My gut feeling tells me it has something to do with the fact that valence shell is second shell, but I do not have any solid reasons for it.
Okay.
I'm assuming this one is clear here, yes?
Yes, sir. Just give me 1 second.
Answer आ जाएगा इसका तुम्हें?
It should come 1 second. This happens and double bond will be. I think B should be correct.
Yeah, that's what I'm basically asking you to check, basically.
Yes, sir. Yes, sir. B. Yeah. So this one, like something.
By the way, I2NaHCO3 can do some other very, very interesting reactions as well. You asked me about other major mechanisms, correct?
Yes, sir. We can send it.
I2NaHCO3 has one more major mechanism attached to it. It's called haloform reaction, which is a major mechanism attached to it. I forgot about that when I mentioned about the other, but it comes under aldehydes ketones only. So it's not aldol, but it is another very, very, very JE focused, extremely critical mechanism.
Okay. So by the way, in that question I was talking about, it was carboxylic acid and not alkene. My bad. Yeah.
Which one?
That I just told. No, there was another question which I said alkene reacts with I2 and
Alkene should not. I mean, it has to be a carboxylic acid.
yes,
Otherwise,
sir.
it doesn't make much sense.
Said also in one question, said will KMNO4 react with alkane?
Of course.
To give what?
To destroy the double bond completely.
But the alkane.
Alkane or ena?
AN.
ENE or ANE?
ANE.
ANE, there is only one case it will react with.
Sir, this is tertiary case I'm talking.
Tertiary.
Oh.
NCRT, go to NCRT and check it out.
Which chapter, sir?
NCRT hydrocarbons.
Okay, I'll do that.
You have NCRT textbook with you now?
Yes, sir.
Pick it up. Take it. This is one of those very shitty things which is only there in NCRT, but it's there in NCRT. So it's fair game everywhere.
That's what I wasn't.
One of those things which teachers will miss out on discussing in class. And since it's there in NCRT, it will come back to bite you in both JE mains and JE advanced. You'll get alcohol.
Inside.
Get it. 11th standard NCRT hydrocarbons. You have it near you only, na?
Yes, sir. Yeah.
Cool.
Oh, this is cool.
Check out the first organic chapter.
Yes, sir. One second.
Switch on the light and search peacefully.
Yes, sir.
Yeah.
There it is. Okay. In some tiny corner is there.
Yes, they put it there. But it is there in NCRT. So you have to know that shit. And nobody does that in school. Everyone skips it. I mean, JE type of people. Because it's meaningless. It's like one off crap. Nobody cares about it, but it's there in NCRT. So you have to know. This is why I'd asked you to make sure you go through your NCRT seriously at this time. During the 11th standard examination, the one thing I'd asked you to do was go through NCRT and check out all these points and put them down. Because you will never touch that shit book again. Sincerely. Especially physical chemistry and organic, you will not touch it again. Inorganic, you have no option, so you'll go read that again.
Yeah.
But physical and organic, you will not touch that book again. But they have these kind of irritating little tidbits over there. Both in physical and in organic, they have these kind of... Don't look at them as things where you have to have logic, reason. No. NCRT is not for logic and reason. NCRT is for data, information. And these will come back to bite you in the ass again, both in JE mains and in JE advanced once in a while. And it'll feel like, why the fuck did I not see this? No, seriously, you can't guess the product in this kind of reaction.
That's right, yeah.
It does not make sense. But it will be there. And because it's given in NCRT, no one will even argue about it. You have no right to argue now.
Yeah.
So you have to make sure this kind of shit is basically taken care of. I think I already told you what type of shit to check for in physical chemistry part there as well. I remember
that one example.
Yes, some JE advanced question.
Yes.
Some connecting shit basically. They will not ask you directly in JE advanced.
Yeah.
But use this to basically, what to say, this will be the crux of a question which you cannot solve without this.
Okay.
So So make sure you are taking care of these kinds of things. For instance, if they give you a question where they're giving you this kind of, say, tertiary butane, and they're going to be asking you, what to say, the fellows reacted with Cayman, you get some product. That product, they are doing some elimination reaction, some dehydration reaction, and that fellow, they are doing some what to say, some ozonolysis followed by some aldehyde ketonola reaction.
You can guess it.
You can't even touch it.
Oh.
You
So
can't
like
guess it so well.
in
Because
this
it's
question,
multiple steps, right?
yes, sir. Yeah.
It goes to multiple steps, you are lost. You will get lost.
So actually here,
Things, they're not going to be fools. They will make sure in this, they will give you some other possibility which looks very plausible.
okay.
Wherein, for instance, if I gave you, say, tertiary alcohol is one product here, correct? Let's say I gave you other possibility as formic acid and, say, acetone. Plausible?
Yeah.
With KMNO4, let's say one carbon breaks somehow, gives you formic acid and you get acetone over there as the other product. Sounds very reasonable.
Yes, sir. Yeah. I was thinking that even.
What are you supposed to do there then? And if they connect with that shit and they give you one more answer over there,
yeah,
you'll be stumped completely.
Yes, sir. Yeah.
And since the JE Advanced, MS Chauhan, and the blue color book and all of those logic tells you the more weird answer. What will you go for? The weirder option?
Yes.
The one where you spent more effort in?
Yeah.
See, if someone gives you an advice for free, you're not going to follow it. But if someone tells you that I'm going to charge you $1,000 and gives you the same advice, you'll follow the $1,000 advice.
Yeah.
Yes, it is just $1,000. It's not that much more, but you'll follow the goddamn advice because you paid $1,000 for it.
Yeah.
And in this case, $1,000 is basically going to be metaphorically the time you invested into it.
Yeah.
So you have to basically pay attention to NCRT, not for logic, not for understanding, but for these kind of nuggets of pain. I suppose that's the ideal way to put it across here. To avoid them at least.
Yes, sir. Yeah.
Next up.
Sir, how do you remember the NCRT?
Dude, you have a similar kind of brain to mine. Let's not bullshit here. If you have basically read through something seriously once, you will fucking remember, right? Why are you bullshitting with me, or you go bullshit with somebody else? Don't ask these kind of stupid questions. If somebody else had asked me, I would have told them some other answer. No, not for you. You don't deserve that kind of another answer. All you have to do is pay serious attention and read through that shit once. You have not done that yet.
No. Yeah.
Right?
Yes, sir.
Then do that. How complicated is that? It's 25, 30, 40, 50 pages.
Yeah.
I know for a fact, for someone like you, it'll take you 10 minutes of serious focused reading to finish one side.
To finish what?
10 minutes of serious focused reading to finish one side in NCRT. Nothing logical is there. So you're not going to really understand shit over there. 10 minutes of focused reading is going to be done. That page is like more or less like what is needed is stored in your brain. Spend that. What kind of a question is that?
Okay, sir. Yeah.
No. Am I right or wrong here? If I'm wrong, I'll give you a different answer.
No, sir.
What I know of you tells me I'm right here. Get it done. It is not that complicated. But only problem is this. People like you, people like me, have a tendency to overindulge when we are doing NCRT. Try to find meaning, try to find connections and shit. No. The best way to avoid it is time yourself. Forcibly time yourself. Keep a goddamn timer. If a side is going beyond 10 minutes or 15 minutes, you close that side. If you're at 10 minutes in or 7 minutes in that side over there, see, why do you think I wear this shit permanently nowadays? When I'm working, I put timers. Because when it is a boring task now, what I do is I procrastinate in my brain. I think I'm doing something meaningful, but I will think only. And time will pass. So what I do is I just dump timers on this. I work on 10-minute timers, 5-minute timers. There is a Pomodoro technique or some shit like that.
Yeah.
some bullshit management technique and all, they work. Especially for idiots like us, it works. Where our real problem is the fact that we get lost in our own brains because they love to make connections. So we have to, it's like we have a rabid beast, which is extremely powerful, which you know is extremely powerful, but it is not under your control. So to bring it under control, you have to forcibly like put leashes on it. And when it is going out of leash, the first thing is you need to recognize it's going out of leash. Wasting half an hour, 45 minutes reading one side in NCERT. What a goddamn waste that is. You have to really put yourself on like a very strict timer. I would say a 7-minute, 8-minute timer would be ideal for you if you're doing NCERT. Put yourself on an 8-minute timer. If you have not finished that one side, inorganic, I'm not talking about it. Inorganic, when you're making notes, you do that. Physical chemistry and organic chemistry chapters, put yourself on a goddamn strict timer. 7 to 8 minutes per side. If you're overshooting and what that means is, let's say you're doing a side. If you're done within 7 minutes, move on. No problem. If the timer is ringing, that means your job is to hurry the fuck up and finish it in 3 minutes.
Yeah.
You will automatically start focusing on only what matters. You will ignore the crap which is going to be some random dudes. What to say? How does it matter to you how that fellow has explained something which you already know? You're not judging the dude shit over there.
Yes. Yeah.
You have to start learning how to read. Reading is a very, very important skill. I also have not yet mastered it properly. When I say reading, I don't mean reading. It's about reading bullshit. Like there's too much stuff which you already know, but in between there are nuggets of information which you do not know. How do you not waste your time with the trash there and the junk there and only pick the nugget? That is a very useful skill. So the reading is like you have to force your brain into reading in different styles where you focus on every word. For instance, if I'm reading some very serious poetry by, say, Khalil Gibran or someone like that, someone really intense, some real philosophical work, there I have to read every 2-3 sentences, 2-3 words even carefully and think again and again and again to see whether it's connecting properly. Those things are different. In that kind of a place, the reading is going to be very intense. I will take like an hour or an hour and a half if I'm reading even half a page. Like say, if I'm reading, say, Dostoevsky or some serious work, which I know is going to be impressive, and I have to invest that kind of time, then I'll have to really invest the time. If I'm reading some Chinese novel, which is like Google translated, I have to learn how to read that also. You understand what I'm trying to tell you here?
Yes.
You have to basically, NCERT reading is an art. Forcibly learn it. In organic chemistry, you have to do serious, that type of pay attention to the details and read. Physical and organic, it's a timer-based game. Your job is to basically focus your brain into identifying what you do not know there. That's all. What you know, skip. Don't even care about it, just skip.
Yes.
Fair?
Yeah.
Start doing that.